All right, in this lesson we're going to learn how to factor completely. In this, when we're factoring completely, we actually want to start with the first step of always checking for a greatest common factor. So with the first example, x squared y minus 3xy minus 10y, we want to see if there is a greatest common factor, or a GCF. So what do each of these three terms have in common? And immediately I notice that each of them have a y. Okay. I also want to notice that there's only two terms that have an x. There's two terms that have a number that isn't a 1. So there really is no number or no x that they have in common. It's just the y. So what we're going to do is we are going to divide each term by y, just to take out that GCF. And what it's going to look like now is I will have y with a big parentheses, and inside the parentheses will go my new expression. So I notice y divided by y, in a way they kind of cancel each other out, which just leaves me with an x squared. Again, y divided by y leaves me with a negative 3x. And then a y divided by y leaves me with a negative 10. And so as I continue to factor, I will be working with this new expression, the one that's in the parentheses after taking the GCF out, taking the y out. When I write my final answer, I will have y in the front, and I will have my two parentheses, which will be my factored expressions. So let's go ahead and figure out what those are. So remember, for factoring, we take the a and the c, making sure they're in the correct order, and we would put them on a diagonal with each other. So x squared and negative 10. I would also multiply these diagonals, and I would get that for the top of my diamond problem, because this is where the product will go. Okay. I know that we don't know what this diagonal will be, but I know it will equal the same multiplication as this diagonal. So I put that there. What goes on the bottom is that middle expression, or that middle term, negative 3x, and this represents the sum. And so we want to think of two factors that multiply to be negative 10x squared and add to be negative 3x. I know with the x squared, they will both have x's, and now we just got to figure out the numbers. So for a 10, I think about my factors, so I brought out my little multiplication sheet. I'm seeing 10 is, or really we just want to find where does 10 show up on this sheet, right? And I'm seeing for the most part it's just kind of 5 and 2. There's also 10 and 1, but I'm thinking 5 and 2 is going to be our factors, because when I subtract 5 and 2, I would get that 3. So I'm thinking about that negative. Okay, 5x and 2x. 5x times 2x makes a positive 10x squared. So now we just got to figure out, is the 5 a negative or is the 2 a negative? And if I want it to add up to be a negative 3, I know the bigger number should be the negative. So I can take the negative 5x and the 2x, put them in the other diagonal of the rectangle, and now I'm just figuring out the dimensions. So the one that I like to start with is the x squared. I think of this as a multiplication table. I do x times x to get x squared. I'm thinking of, what do I need to multiply x by to make a 2x? That's a 2. And what am I multiplying x by to make a negative 5x? That is a negative 5. So in our parentheses we have x plus 2, x minus 5, and we can highlight that because that is our factor form. That's our answer. So let's check out a second example. just a little bit more complicated. We have 3x cubed minus 6x squared minus 45x. So if I'm thinking of a game plan for the GCF, we want to start by just looking at what do these things have in common. I mean, I'm looking at this problem and I'm noticing I've got an x here, an x here, and an x here, right? This happens to have like x times x times x because it's x cubed. This is x times x, and this is just an x. So each of these terms has at least an x to it, right? So I know when I go to divide each of these things, I can divide an x out. Now there is one more thing to it. There's actually a number as well. I notice a 3, a 6, technically a negative 6, and a negative 45. If I check out my sheet, my multiplication table, I actually notice this is not quite big enough, but I notice that 3, 6, and 45, they are all divisible by 3. So I'm actually going to divide a 3x out of each term. And so when I'm writing my final answer, I will have 3x in the front. And, you know, when I have my final answer, my factored form, it should look like this. Okay, so let's do a little dividing. I know 3 divided by 3 cancels out, or just turns into a 1. If I have x cubed, which is x times x times x, and I want to divide an x away, basically I'm getting rid of one of these x's. So I will be left with x squared. Next, negative 6 divided by 3 is a negative 2. And x squared divided by x, again, think x times x. We scribble away one of the x's, so we're just left with 1x there, x to the first power. And then finally, 45 divided by 3 is negative 15. And we see the x's would cancel each other out. So this is the new quadratic that we're working with. So let's go ahead and get into our factoring. We take the a and the c, and we put them on a diagonal with each other. We also multiply them to get the product, which is negative 15x squared. The term in the middle, negative 2x, goes on the bottom. That represents our sum. And now we want to figure out two values that multiply to be negative 15x squared and add to be negative 2x. So I know x and x times x makes x squared. 15, let's see. If you're needing to like set something up just to keep yourself organized, we can make some factors for 15. So I know 15 is 1 times 15. It's also 3 times 5. So you could like actually list out the factors as a means of like organization. And I'm thinking 3 times 5 is going to be kind of my best bet. And the reason why I think that is because I know if I subtracted these two numbers, I'd get that 2. And subtraction is kind of the way to think about it, because I notice when I multiply them together, I should get a negative 15. So that means one of these numbers needs to be a negative. They add up to be a negative 2, so that tells me the bigger number should be your negative. So now I just put those in the rectangle on the other diagonal, and then I figure out my dimensions. So I like to start with x squared. It's just x times x. 3x, I know this would be a 3, because 3 times x is 3x. This would be a negative 5, because negative 5 times x is negative 5x. Negative 5 times 3 is negative 15. And I can just put these dimensions into the parentheses. So we got x plus 3, x minus 5. So these are examples of factoring completely. And factoring completely just means if there is a GCF that you notice in the original problem, you need to factor that GCF out first so that all of the terms in the parentheses are completely factored, completely simplified. All right, thank you.